All right, welcome back. Now, as we continue in this course, it is now time to extract our facial landmarks from the face of the subject we are using. Meanwhile, the goal of this particular course is not to teach Python or R. Okay, for any user of this particular course, it's expected to understand at least basics of Python or R. So it's not is to teach research approach, not to teach Python. Want to learn Python? There are other platforms that you can actually learn that before you jump into this. Okay, so that's by the way. All right, so we want to quickly look at how to extract the facial features from the faces. Now, you need to first import, or rather install, OpenCV, CV2, and the library. Okay, then you can if you have installed Python, I install Python. This is called PyCharm. Okay, this is PyCharm. Okay, you can download PyCharm online. It's free and install. And before you install a PyCharm, you must have installed Python before. I installed Python using Anaconda. You may use other main, but Anaconda is easier and is very good. So you can install your Python using Anaconda. Then after that, you can install PyCharm. PyCharm is just IDE. Okay, then you can there are so many other IDE you can use if you don't want to use PyCharm. But I'm using PyCharm because I find it more convenient. So this is our code here. In other IDE, the way you install your OpenCV, the way you install your library may be a little bit different, right? But in PyCharm, it is easier. You can go to setting from your file. You can go to settings here, settings here. Yeah, so you can these are packages I have here. You can see these libraries here. All right. You can also see okay, I have a OpenCV also. I'm trying to locate OpenCV here. This TensorFlow, but I'm looking for CV. Okay, this let me see. All right. Okay, this is it. OpenCV Python. So these are two major things you have to install. You are going to write OpenCV -Python. So you are going to install it from a just for you to install, just click here, plus here, and types and search. Right? If I type OpenCV, right? Already installed actually, but open that CV now. OpenCV Python. It's already installed. So if I go to the library, for example, okay, I can just already come. I've just click on install package. So when you search for it, just click on install when it comes. So that's how you install the library. So that's how I install OpenCV Python. So and the library. Okay, you have to install those two major in your your Python environment. Okay, so that is just how to install those ones. So this one is not needed. Just import this. Don't to install. It's automatic. That one is inbuilt to use a directory and files management. So we need OpenCV, which is CV2, and the library major file for you to manage to run this particular program. So now we want to pre-train the face detector and facial landmark predictor. Now the first line here shows that by the way, before we go further, I'm going to be using test face first. Test face, this particular test face, this image folder. If you look at my folder here, okay, we have test phase. All right, I have Williams folder. This is a folder that contains all my my subjects, okay, for Williams syndrome, and also have another a fragile X syndrome. This contains 60 and 60, but there are just only 4 here. So if you open my folder here, you see inside this my PyCharm folder, you see test phase here, you see fragile X here, you see Williams here. This you can see if you touch it, you see how my folders are names. Right, you can see F01, F02, F03, F04 to 60. All right, that is this one also what shows W01, W03, which means I'm giving them specific name, which means Williams and fragile. That's what it means. So I named them, but if you look at this one, it's showing test phase, test 1, test 2, test 3, test 4, which I've shown you before. I'm going to be using this one because I already published. Okay, I just crop it from the journal to test. Okay, I'm not going to showcase display the faces of the fragile S and Williams. I'm not authorized to show their faces, so but I'm going to use this one to test first before we're going to use this and this. So I'm going to showcase all this so that you can see how it's working before we run this and this. All right, so let's go back to our PyCharm now. So they are in my folder. You can see them here in my. So you have to create a project first, new project. So that should be easy for you to undo in a PyCharm. Then you create a file. So now this first you have to install. You have to download this particular one. Download from this website. Okay. This is 60 shape predator 68 face landmarks .dat.bz2. So you have to download this first. Then you copy it and paste it in your, like you can see it's here, right? This is it here. I'm sorry, this is it here, rather. Right, this is it here. I downloaded it, I pasted it. So you can see it's here. All right, so that is important. Sometimes you may find this particular library difficult to install sometimes. Okay, this one, if you find difficult to install, it's not running properly, you can download it directly from their website, download from here and copy into your directory. All right, then run it from here, here and install it. It will now install. So sometimes it may be difficult for you to install. Just download it and copy your directory, then run it from here and install it. All right, so as I was saying, now this is a code. We need to first let's create an object called detector and assign the library frontal face detector to it. So this frontal face detector will detect the front face of human face automatically. Then predator, another object predator, we create predator object. We now say we assign the detector. We say okay, the library shape predator. We copy our what we downloaded here. This is it. Okay, we pass it here, right? So we need these two first to start, detector and predictor. All right. So now you can continue. Now say our image path, our folder path. We have it's an object, another object here created here. We assign our folder name to it. So I'm going to be assigning each of the folder to it one by one. This folder we assign to it. I don't want to copy everything in one folder. That is why. Okay. I want to separate so that I can have the proper names for them. I can arrange them as I want. But it doesn't matter. You can copy them together on the same folder if you like. So I just decided to separate them, okay, so that I can manage them properly later. So now I'm going to use this particular folder test phase. There are 4 images there in PNG, okay. You may be in JPEG. It doesn't matter. So now I've done that here now. So now I want to save it in form of TSV. You could use CSV. I just prefer TSV, all right. Comma separate value CSV, and TSV means tab separated value. So both of them are okay. Any one of them will work. So I'm trying to write now. So I'm going to create a new object now. I'm signing my file when I'm going to save it in TSV. When I'm finished, what am I going to save? I'm going to save my coordinate file, because I'm going to extract the coordinate from human face, the coordinates, all right. From the faces, I'm going to extract it and save it into TSV file, so that when I open it later, I can now run it later. And this file format, this file must be in a particular format. It must be in a TP file format, because I'm going to convert later to TPS rather. That is thin plate spline. This is a morphometrical file extension universal. It's very universal, whether for MorphoJ, whether for pass, whether for R. They all recognize or morphological or morpho. All of them they recognize TPS file. Okay, it's universal. So it has a structure, it has a pattern, and this is the structure. All right, let me first show you the structure, and this is how it look like. Landmark 32, right? The total number of landmarks that you are going to place on the face must be specified, which is we already have 32 landmarks we want to use. Then this is a S1, Y1, S2, Y2, S3, Y3, which means that for each of the points, okay, it's a coordinate. We have coordinate 1, coordinate 2, coordinate 3. That's what it means, right? So S1, Y1, S2, Y2, S3, Y3. The ID is 01. You can give any name you want, any ID you want. Sometimes you may prefer to use IMG, image equals to 01, right? .jpeg if you want, you can add to it, but I prefer to use ID, so you can use image or ID. Anyone is okay, will work. All right, so this is first set, all right, for the first specimen. Then the second specimen, same thing, okay. Third specimen, fourth specimen. This is a structure until you finish all the specimen. This is how you look like. All right, this space is not needed, okay, but I just put it there to see what I'm doing. All right, so this is what they call TPS file structure. Right, this can be read by any morphometric or morphological apps. Right, so I'm going to be seeing how that will be handled later. So now, if you have this structure like this, I want the Python to save it in this format for me, in this format. So that is what I'm trying to do here now. So, but you first create this file name first. Okay, this file name. Now with open TS file path, right, this right now, new line to as TSV file. All right, so we have to process each image in the folder now. Our folder called test face. So for image name in this folder, now we have to, if the image is JPEG, JPEG sometimes can be in this form, can be in this form. So sometimes because of the application you need to create the image images were created from, sometimes some are naming this extension why in this extension, so they may have challenge in that area if you don't know. So that's why I have to put here JPEG here, because some of my images are JPEG, some of them are PNG. All right, so if you have other extension like a TIFF, you can add to it, okay, so that you will not miss any images. So you must have checked your images and make sure that they are in proper extension before you run this, okay, because sometimes it will miss some image name because of their extension. If you cannot capture the exception properly, then the image will skip the image. All right, so I don't want it to skip any image because my files are in JPEG and PNG, but the one I want to use now is just purely PNG. This test face is PNG, so that's no problem. I just leave it like this for the sake of the other work. So image path, I have designed that OS path.join image file. So I'm passing the image folder and image name into it, to this path. Then frame, I'm reading the frame, okay, image from the image path. Then the color, I'm trying to choose the color, this grayscale color, convert to color. Then faces, now I'm calling the face detector now, which is here that I created here. I'm calling it now. I'm still passing this grayscale to it. All right. Now I'm going to loop now for each face index in my face, enumerate my faces. The landmark is equals to predictor grace faces. So I'm passing the predictor grayscale to I'm creating another one called landmarks. So this is a object I'm creating now for my landmarks. Now I'm now going to extract an array. This is an array of landmarks points now. And this is very important. This particular line is very, very crucial because this is where our landmarks selection comes from. Okay, look at what I'm trying to say now. If you go back to our slide I showed you all last time, okay, you can see scroll further, you can see these are 32 landmarks now, right? I'm trying to extract out from the general facial landmarks from this particular 68 landmarks. I'm trying to extract 32 landmarks from it, all right? So now, if you look at this, my slide here, I showed last time, from here, these positions of landmark is what you are using now. We don't want all these landmarks. We want just specific landmarks, biological points only, okay? Because not all of them are biological in nature, okay? Some of them are just blank. So we want just to specify. You can decide which one you want, okay? I only want only 32, all right? You may want this and this as well. You may want other one from the faces, but I want only 32. So I just why I pick. Now, if you look at what I pick, from here, I pick 46, 43. This is 1 and 2. This one is a new order. All right, this is a new order. I will show you how I arrive at this later. Okay, this particular one, because when you finish, when you are seeing in PyCharm here, in Python here, is the one from here, not from here. All right, this one is a reorder. You go to rename it for you. You go to give a new label. This is a relabeling, okay? Because after you are finished, it's going to readjust to a new label later for your own. But for originally, it's going to start from here, because you need to pick from here. Okay, I want 40, I want 37, I want 46, I want 43. That's what you are seeing here. 1, 2, 3, 4. Then I want subnasi here. Okay, I want this. You can pick it from here. I also want 31. I pick 31. I also want 7. Okay, 50. I want 36 rather. I want 11 and 32. Okay, I want 33, 34, 35. You can see this is 10, 9, 8 like that. So I want 55. I want 49, which is this and this. I want this. Okay, 17. That's 58. I want 9. All right, which is 20 here. So you don't use this. Okay, you use this. So this is the position of the landmarks automatically. These positions. So you pick by position. So you have to first test and see, because this particular one is a standard. It's a standard. Okay, this from this website. Okay, from the library website. It's a standard. So you can pick from here. That's why you first import this library first. All right, this one you have to import it first to follow the names convention. They're already there, so you just pick just pick out the one you want out. So I pick these ones I want out. Okay, I pick them. I assign them to anatomical landmarks. I created this one. Okay, I let it be assigned. This is an array assigned to this. So this is what I'm going to process now and put on the faces. All right, of the position. They already have their positions already. So I'll just extract it out and place it. Now I want to write the coordinate of the landmarks now. tsv.write. I want to write in tsv file, like I told you before. The one could be csv file.write. Same will work fine. All right. So I want to append these strings to it, because I want to follow this format I showed just now, so that I won't be doing extra work later. Okay, I just want it to be in this format, so that I just save it as my tsv file later, so that I won't be doing any extra work in case I have a lot of landmarks. A lot of subjects. I don't need to be doing extra. I just follow this pattern of extension. Of file name convention. So I will just I append this to the total of my landmark. If your landmark is 28, just put 28 here. If it's 50, put 50 here. So because this is following the TPS5 format, that's what it's saying. Now for landmarks in anatomical landmark in this particular my array I created here. Okay, I'm going to extract SY coordinate. Okay, S and Y coordinate landmark. So this landmark.path is what we extract from this particular, because that particular we brought here now. This one we downloaded. It has a predictor. Okay, shape extension. So inside it has what they call landmark.path function. So I'm going to call it. I'm passing my landmark to it. This is my landmark. I'm going to pass it to it. So which I'm already creating. So this landmark I'm passing to it now is my SY coordinate for S for Y. So it's going to say landmarks.path landmark.s same thing .y. Okay, I'm passing it to it now, so that I can extract my S and Y coordinate, then write the CSV file. Now the F here is talking about the string extension S, Y, but I don't want to use I don't want to use S, Y. I want to use X. I will have used S, Y if I'm using maybe CSV file. So this tab will not be there. All right. This means tab extension, which means type format TSV. This means because I'm using TSV here, it's going to be tab. All right. Show me in form of tab. Okay. S, Y. It won't be S, Y. Go to S space Y. I don't want comma. Comma should not be there actually. So that one I will need to be editing again later. I don't want spam. So but I can just use one space instead of a S, but I want a tab to make it very clear and clean. So this means new line. All right, so write the image name without the extension after the coordinates now. All right, so image name here, we are going to write a name. So we don't want the extension to be there because image name will come with the extension, JPEG, PNG, whatever. I don't want the extension to be there. I want to use my ID here, like I say for this ID. So every image has a name. For example, now in my this thing now, in my test phase, it has a test, that's a test, okay, that test, okay, test 1 and test 2, test 3, test 4 dot jpeg, all right, that's what is there. But I don't want this one to be showing this jpeg. I want test 1, test 2, test 3 only. All right, that's what I want to do. Also is in same thing in my Williams folder and Fragile folder. I have something like that. Same thing here. I have f01, f02, f03.jpeg. So I don't that one. So I don't want that to be there. I want only f01, f02 like that. That's my name convention. So remove the extension. That's what I'm saying. Remove the extension. Okay, and the ID equals to, so this ID here equals to the name, the file name of each of the without the extension. So now that is what we do here, and break down each of them to a new line. Then draw the landmarks on the frame with red dots. So we're going to put dot on each of the face. Position this SY coordinate now. Let it be circle it, put it on the face. So I'm using -1. You can increase it to maybe -2 and see. All right. So this is what I'm using. No, rather this one. This particular one is make it to the size. Okay. This color. Okay. This color. You can change the color if you want. So we have a RGB color conversion. So just change the color. I'm using 00225. So you can change the color to any other color. You can change the RGB color conversion online for each of the color. So you can change it to 1 to 2. The color will change automatically. So just check online. You'll see the name conversion. So this color is red. This one is red now. Okay. All right. So then the size is this. Now draw a green square frame around the surface. So we want to draw a green frame now for S1, S2, S1, Y1, S2, Y2. So we want to measure face left, top, right, bottom. So we want to draw a rectangle. That's what it means. So this is what we draw. So the rectangle color is this is light green. This is a color for that. Okay, light green. We want it to be thick is 2. All right. This one is just -1. So you can change them one by one to see the difference. Okay. If you want more thicker, you can make it 3. All right. But I don't want to more thicker. I think 2 is enough for me. It's okay. All right. So save the output image with landmarks and square frame. Okay, you call this now. You set output. So call it image f output.image. All right. We write it output in the frame. Now we want to display the frame now. This one we're going to off it later. We don't need it actually. But I want you to see how the thing is running. That's why I left it like that. Later we're going to comment it. We comment it so that we don't need to. If you have 1,000 images, for example, this will waste your time. But what I want you to see it is that I want to see how it's working behind the scene, so that you can just understand that it's working. But you want to see how it's working. It's going to be showing the frame one by one as it's putting the landmark on their page, on their faces, and it's going to be showing you one by one. So this is the frame line. So the key is just 1 seconds, and you're going to see it one by one. So we will have this and this later. We will off it later for other ones. But now we're going to display it and see how it works. So now let's run this code and see what I'm talking about. Don't forget, we're using only 4 images to do this. All right, those images is here. All right. So when we finish, the new images that will be created will be here with frames and points on them. We don't need them, but I want them I want you to see them. That's why I want to place them here. In your own tool, they will be placed there. Then you can delete them later. Maybe you want 1 or 2 of them to illustrate in your manuscript or in your thesis. You can extract them. You can just put 1 or 2 in your thesis to show that how you do this. So let's run this. Just click on run here. All right. If I click on run here now, to run from this test phase folder, and we'll create a a file called my test phase coordinate.csv, which I created. So let's do that now. If there's no any error, let's see, starting now. Now, so you can imagine, you can see, so that's what it's doing. That's finished. So it's giving me one by one. I can increase the time here. All right, the time of keyframe here, just 1 second. Okay, I can increase to maybe 3 seconds so that I can see properly. But I don't need to do that. Why I show you, because sometimes some faces maybe if your image is not good enough sometimes, or if a file name is missing, some may be missing. Do not place any landmark on it. You will not see the frame. So you know that, oh, something is missing. Then you can do that later. That is why I show you, so that you can know. All right. So now let's go back to that folder now. Don't forget, we have created a file name. You can see the file name has been created here. Can you see that? Now let's now go to the folder now and see what I'm talking about. See the folder. We have this before, so it's giving us this output_test, which is creating here under this. Okay, this was output underscore image name. So creating out a new file name of each of them automatically. All right. So now if you zoom this out now, you can see. Look at the points. All right. Look at the points we are talking about now. All the points. All right. Second one. Zoom out. You can see. You can see it. You can increase the point if it's too small. Okay. If it's too small, you can increase the point. But at least this one is to me, it's okay for me, right? It's okay for me. But for your own, if your point is too small for you, can increase the size. Okay. You can increase the radius. Okay. This is the third one. And this. Look at it. You see, why the mouth is open, it will pick. When it is closed, it will pick. So it can recognize opening mouth and closed mouth automatically. That is the power of this. So whether it is turned left, you can see, I think the position of the head is not properly straight, but yet it can recognize it. Okay, you can understand what I'm saying. So when the mouth is closed, it can recognize. So you can see this one is you can recognize the up and down. Can recognize it. There are 2 points here now because the mouth is closed. That's what I was showing you here in this folder. In this slide, you can see here when the mouth is closed. Okay, but when it's open, you can see properly that, oh, it's open. But when it's closed, okay, so let's look at it when it's open. All right, you can see one up, one down here. When it's closed, it will look as if they are on top of themselves. All right, so this is how you extract them out. We have extracted them out now. So, but as it is now, it's already repositioned them with a different label for us. But you cannot see the label now because we didn't put label on it. Maybe you can improve on your own Python and add label to them, new label to them if you like. Okay. I don't want to do that. It's not necessary for me. I will show you how to get the label later because it has a label, all right? Because it's going to readjust them and give you a new label. So the new label you are having is what I'm using now. It's a new label, okay? So, but this was what we use to code it, extracted to code it. So don't forget this. So now that we have done this, now let's go and check our output, our result. This particular TSC file that I'm talking about. Let's open it, okay, and see how it looks. So it's in our folder here, right? This is it. All right, this is the file. Okay, look at it here. Right click it. I open it in Notepad++. Right. No, let me see. I think I already have it's at 32. You can see 33 here, and minus 1. So this means from 2 down to 33. 33 here, making 32 landmarks. All right, S1, Y1, S2, Y is like that. So this S32, Y32, that's what it means. All right, so ID is test 1. You have to remove .jpg out or .png out. Now, then the second set is this L32. Do the same thing for the second set. Okay, put the ID here. Test 2. The third set is this. All right, that is a third subject, and the fourth one is this. Can you see? Fourth subject. So if you have 100,000, that's how I'm going to do for you. This is the format I want it to be, so that I will not stress myself and be adjusting, restructuring, removing points, removing. I don't need to do that. It will be too hectic for me. Okay. So and likewise for you as well, because you don't have time. So you want to minimize time. So you can now save this file now as what? TPS. How do you do that? It's very simple. Just come here, file, save as. All right. Now follow this instruction carefully because that is where you might have challenge. So open this here. Okay. Say all types. No any kind of types. You say all types. All right. Then click here. Okay. Click here. I'm dot uppercase TPS. Can you see? TPS. Can you see? That is all. That's all you need. Then click on save. Can you see? It's as safe as .tps for me now. So this particular TPS file now, I can run it in any morphological application, like maybe both in R, in Python, in MorphoJ, in Parse, in morphological, in Morpho, and any other that I can run it there. They all recognize this TPS file. It's a common file, though they have what they call NTS file as well, but the common file is also TPS file. All right, so this is what we need for now. Okay, in the next class, I will go further to see how to handle this, because this is what we have extracted. We are going to process this one in R. We use how to process to extract our PCA from it. All right, PCA will be extracted from this one. Okay, then we're going to keep it for further analysis later. All right, so I want to thank you for this. So just remember that we use okay, I've not finished actually. We need to now, this is just a sample. That's how you do it. Okay, so we can now go back and do it properly and run this now. I can now change this one to my original Williams, okay, folder. Okay, let's say William folder now. I could say Williams. Oh, sorry. All right, so this is my folder, Williams folder. All right. Now I change the name here. Maybe I want to change the name here to maybe my Williams. Let's say my Williams coordinate. That one will be fast because I'm not going to show the faces. Okay. If you don't want to show the faces, it'll be very fast. Just 2 seconds already, it's done. All right. But because you want to show the faces, the more the faces you have there, or the images you have, the more time it takes. Okay. Because you want to show you one by one. If you have 100, you can show you all the 100 before you stop. Even though the file will be created at the end of the day. But if you don't want to show the face, you can off it here. Just off it here. Let me just go here, come here and off it here. All right. I mean here. Just off it here. I don't want to show the faces. Meanwhile, I want to compute the. All right. So this is what I have no faces showing now because I don't want you to see the face in the first place. Okay. So that is why I off it. All right. So if I can run this now, all right, it will give me 32 landmarks automatically and ID of each of them, which I'm going to see later for this. So this is what I'm going to do. So if I run this now, I'm going to create this for this and for fragile S. So I will now combine them together. Okay. So that's what I want to do so that I can have separate file for them. So if I run this line of code now, it has finished. All right, just in maybe 3 seconds, it has finished. So which means it has created a file for me called mywilliams.csv. So let's open that now. Can do the same thing for. I'm going to do the same thing for this also. Let's do that once and for all. What is name now? Fragile X. That's our folder name. So let's change this one to fragile also. Fragile, so that we know that we have a fragile X. So coordinates. So let's run this as well. Okay, it's already off here. I'm not going to see. We're going to see the face. All right, we don't need to see the face. So let's run as well. That's finished also. So now I have 2 of them. You can see here. You can see fragile S here, Williams here. So let's go and open them. So only the coordinates you're going to see now, not the faces. Okay. So let's go there. So the faces are in the folder in the file here. Okay. And here I don't want to open that. So we are going to open only the coordinates which I just created now and save as TSP file. The first one is this. Open in Notepad+. You can see here. You can see the name FO1, FO2, FO3. Go down to I've deleted them now. So this is what we need. Okay, this is how your own will look like. Okay, don't mind mine. So it's because of I left this folder there. So now the same thing happened to Williams. Okay, I just do the same thing for Williams. If you open the Williams, same thing there. So I just copy. For example, now I can copy everything here. Control A, copy. I go to Williams. I will paste it there. Paste down there. Okay. For example, if I open Williams now, here, Williams, this one have the same thing. Can you see? Williams W01, W02. Okay, so I've just paste it here. Okay, all right, that's all. So I've combined it together now. So I now save them as what? CSV file, TPS rather. So I can just call it my combine. Example, I want to give a new name. Combine coordinates dot TPS. Open here. Of file types. Don't forget that. Okay, it's very important. So I save. So I have a TPS file now. So that is all you need. Okay, this one now is our combine everything we are going to be doing later, using later. All right. So I'm still going to, I can still change the name later. Okay, but at least let's leave at my combine underscore my combine coordinates. Okay, for now we can rename it to suitable name. All right. So we have combined combination of Williams and Fragile here now. So that is that for now, what we need for now. So I hope that this one is very simple and very clear enough to extract your landmark physics. So we're going to be running a PCA later in R. So thank you so much for listening. I will see you in the next class. Thank you.